Hey y'all, welcome back to another Robinson rant. And yeah, let's get at it. I just said I said that I would have another example problem, so here we go. Have at it. At it? Yeah, good. So I'm just gonna let's just plow through it. And for sake of trying something else, let's go ahead and try something like mesh current. I'll go mesh current here. Current. And I'll go ahead, since we're interested in finding that I'm going to go ahead and set this to go clockwise. And I'll call that mesh 1. I'll call this one mesh 2. And call this one mesh 3. 3. Yeah. And so our mesh current, well, let's go ahead. We'll walk around. And I have a jump of 136, excuse me. And notice again that we have a phase of 0, which means that initially starting out, this thing is only in the real direction. So you could interpret this, if you prefer, as 136 cosine of omega t, right? That angle is saying how far from that starting position. Okay, well, very good. So mesh current, we have a 136 volt jump. And again, that's referring to the amplitude. And then what do we have? We have our 14 I1 drop, then minus our 40 J I1 minus I2, and then minus our 40 I1 minus I3. And that whole rigmarole is going to be equal to 0. Well, next up. Okay. Next up, number 2. Same thing. I'll go ahead and walk around clockwise. And so I have something like minus 40 J I2 minus I1. And minus, and notice here's where we have to be careful. We have a minus minus. So that actually gives me a plus 15J times I2. And then again, 50 I2 minus I3. Well, last but not least, we have loop 3. And here we're lucky we just have all resistors, so we don't have to worry about double negatives or anything like that. So we have our 40 I3 minus I1 minus our 50 I3 minus I2, and then minus our 10 I3. So go ahead, form the augmented matrix. Go ahead and write down the augmented matrix. Yeah, you got it? Yeah, good. I'll go ahead and write it over here on the right-handed side. But what we're going to end up with is, I'll call it I1, I2, I3 as my column order. And then I'll have my B, my coefficients, if you will. So let's go through. We have 14 and then another 40. So we have a negative 54. Negative 40 J. So that takes care of that one. Okay. Let's see, what do we have? We have a negative, so a positive 40 JI2, J, and a positive 40 I3. And then if I move the 136 to the other side, I end up with that negative 136. Okay. So the same thing that we practiced let's say a month and a half ago. Yeah, just have these imaginary numbers in there as well. So again, 40J for I1, and that's now positive. We have negative 40 plus 15 for I2. Oh, excuse me, let me do the real portion first. Negative 50. Yeah, so we just have that negative 50. And then minus 25J for I2. And then I3 is just a positive 50. And we are stuck with 0. Well, last one. We have a 40 I1. We have a 50 I2. And then we have 40, 50, 10. So we get a negative 100 for I3. And there is my augmented matrix, if you will. So now we can work our magic. I just queued this up into MATLAB and have it solve it for me. And so what we end up with is, okay, I'll use this upper right-hand side since it seems to be the cleanest. We have I1, I2, and I3. And what do we have here? Now I'll give it to you in both Cartesian, the component form, and then I'll give it to you in the phasor form. But we have 3.53 plus 1.88j. We have 3.48 plus the 3.67j. And then finally we have the 3.15 plus the 2.59j. So there it is in component form. Or if you prefer the phasor notation, this is 4 at an angle of 28 degrees. The second one is 5, I'll put 5.1 at an angle of 47 degrees. And I'm just rounding to the nearest degree right now. And I have 4.1 angle 39.4 degrees. Now bear in mind, I would argue probably these phasors, the first I1 would be helpful because that gives you this current. The other two maybe less so. The component notation is probably better because you're going to have to still find branch currents. You know, if you're doing this problem and solving completely, you'd have to find the branch currents, meaning that this Cartesian representation would be better for doing those differences. Cool, huh? Yeah, okay. So again, I can't emphasize this enough. Once you do this conversion into the frequency domain, in other words, you introduce Euler's relation, and that allows you to treat all of these circuit elements like resistors. And so then our techniques that we developed for resistive networks can again be applied with the minor caveat that we have these imaginary numbers running around. And then at the end of the day, and then at the end of the day, you're going to have to remove those imaginary numbers. Now, the other thing I'll point out that I've probably omitted is don't forget that these Cartesian representations assume that you have that e to the I omega t still going on, right? When I write I1 is equal to 4 times the phasor 28 degrees, okay? Or if I write it as this Cartesian thing, please don't forget that what we mean by that is 4 e to the j omega t plus 28 degrees. So it's easy to kind of forget that Euler's relation is still in with that current. Or similarly, if you're doing the Cartesian stuff, okay, the other representation, it's 3.53 plus 1.88j, and that whole rigmarole is multiplied by the ej omega t. Okay. And so if you want just the real portion of that, it's more than simply stripping off the 1.88j, right? You have to do the multiplication through and keep the real piece after you do that multiplication. Okay. So there's my one warning, is be careful. This has all of the information that you need, but be mindful that you might have to extract that information. Okay? It has all the information you need, but if you're ever asked to take this phasor and extract the real component, you still have a couple of steps that you need to worry about. Okay? Cool. Not the shortest video I've ever done in this class, but as I said, I promised another example video, and I don't really see about going further. It's just a matter of flipping open the book and running through example problems. So if you need more practice, feel free to let me know, but I would also encourage you to, flip open the back cover, throw a dart at it, take the problem, and go at it. So at this point, it's a lot of reusing ideas that you've already developed. Okay? Well, cool. I think that's it for right now. I thank you for your attention. Keep up the hard work. We've got our last homework assignments due on Monday. And yeah, we'll carry on. Thanks for your attention. I'll see you next time.